Okay, so here we have a packaged deal, what I mean by that is that we have pretty much ready-made D-Latch, okay? And they do exist in the format of, I just put some D-Latch examples, and here's a CMOS or TTL family here. So 5475 would be CMOS, and 74 would be the TTL family, okay? So you can research the data sheets on these numbers right here and do some comparing or comparisons if you wish. All right, I would encourage you that you actually would see what the differences are between them. It could be the way they operate, or they could be the way they look, or they are shaped. Okay, now what do we have here? We have two types of inputs. First of all, here is the sort of a symbol, if you can say that, of the D-Latch. So we have in one package we have the D, we have the enable, and sometimes it would be labeled as the C, which stands for clock, or sometimes it's going to be CLK for the clock. All right, now we have the data and the enable pin. Please refer to the previous video if you want to really get some details on how these operate. And we have the Q and not Q output. And also we have two new guys on the block. We have the set and the reset. They are not that new. You should be able to figure out what the operation, what the rules of operations are with these. But let's just analyze it a little bit. What kind of an input would that be? Well, this input would be active high because there is no any bubbles, there are no any triangles, rectangles, or what else? There's nothing. So this would be active high, and this would be level triggered, right? Now over here reset would be the same thing. So here's the deal, here's the idea. If this set goes high, that means it is going to be activated because it's active high, which means that this whole device is going to go into the set state, which means Q high and not Q low. On the other hand, if this thing goes back to 0 and this is high instead, not that one, this one stays low, the reset is high, then this whole device is going to go into the reset state, which means not Q will be high and Q will be low. Doesn't matter what's happening here. These are called the asynchronous inputs. The asynchronous inputs do not care about anything else. They override everything. They are not synchronized with any other operation whatsoever. They will just perform the operation as they are told. Okay, doesn't matter what everybody else is doing. So they are called asynchronous inputs. Now over here, the data and the enable or the clock pins, they are synchronous inputs because they work with each other. Okay, one depends on the other. The conditions have to be the condition of the outputs depend on both of them. They work together. They're synchronized with each other. So they're called synchronized inputs. These guys here, they are asynchronous because once this one is activated, it's going to make everything else invalid and not invalid. It's just going to not care about any other operations. It's going to set the device. And this one here will not care about anything else. It's going to reset the whole device. Obviously, these two are never meant to be high both at the same time because you can't have set and reset both at the same time. All right, let's just take a look at the truth table here. Asynchronous inputs. Asynchronous inputs. Set, low, low, normal operation. Please refer to the synchronous inputs. Okay, good, because they are not active. They are not activated because they're active high. And when they're sitting low, yes, they're going to basically be not active. So there will be no set, no reset condition. So it's just if they were not existing. And here, when one of them is high, the other one is low, then yes, we're going to get this thing, this Q high, synchronous inputs irrelevant. The other situation, when the set is low and the reset is high, then the hard reset is going to happen, and the Q will equal to low, and synchronous inputs will be irrelevant. And of course here, if you ever come across this kind of situation when both of them are high, this is an invalid state. Can't have set and reset both at the same time. All right, so okay, so let's just trigger the whole thing into the normal operation. So both of them are low. Are they low right now? Yes, they are. Why? Because look, they are not connected to VCC. If I close that switch, this thing would be high. This point would be high because it's directly connected to VCC. And when I open that, it's not connected to VCC. It's connected to the ground through a resistor. So it's pulled down. So both of them are low. We have a normal operation. Let's take a look at the truth table here. When data and the enable are both high, well, one common thing here, if the enable, there's another way of looking at it. If the enable or the clock is high, if this one is high, then the Q, which is the main output, is going to follow the D, which is the main input. See that? When the clock is high, then this is same as that, and this is same as that. The output just follows the input, and the not input, sorry, the not output is basically the not output. Okay, so yeah, I can just oh, that's not what I meant. Here, I was hoping to highlight this, but I guess I can. All right, so and then when the clock is low, then doesn't matter what's happening on the input, or the only one input we have now, the data. Then it is going, the D-latch is going to keep its previous state. It's going to remain latched. Okay, so when the clock is low, then we have the freeze, everybody freeze situation, don't move. All right, and then until this clock goes high, then everybody is moving again, and then freeze, nobody moves again, and then everybody moves again, and so on. Okay, it's just like a childhood game or something, I'm not sure. All right, so let's activate this whole simulation by pressing this play button here. All right, so what do we have here? This whole thing automatically went to reset position. Well, yeah, because we have low on the it's just, you know what, doesn't matter. I'm not going to analyze that because it's kind of unpredictable when we turn things on. Now I turned the D on. Did anything change on the output? No, because the clock is not high. All right, see here, this is the VCC, and like, for example, D through the switch. If I close that, through the switch, this point right here is connected to high. Okay, if I open the switch, this point is disconnected from VCC, but it is connected through this little wire here, to that little wire here, through the resistor, to the ground. So it is going to be low. And of course the probe shows high and low. So push on for high, release for low. Okay. Okay, so we're going to preset the condition. All right, it is ready to, now the whole system is ready to go to the set position, and it's just waiting for the order. It's just like the soldiers, I don't know, in different army situations. This would be like forward march. Okay, so this would be forward march. Okay, something like that. All right. So now the whole device knows where it is going to go as soon as it gets the go order. All right. Let's see here. So we have this D high, and when the clock is going to be high, then the Q is supposed to be high. Okay, well, let's give it a clock, and then when the clock goes back to low, it's going to stay that way, right? So okay, let's see. Okay, watch this, watch that. I mean, watch this one here. I'm gonna press the button now. Cool. All right. See, that thing just went high for a second, and then it remained low. It doesn't matter how many times I'm gonna press it. Now we have that set to, because it's going to keep taking a snapshot of that. And now when the clock is low here, which means the whole thing is not abled, doesn't matter what I do with that, this input is going to remain latched. Okay, well, here is the D-latch. Now, the one last thing, we're going to, let's just say to, okay, we have this thing set at the set position. So it doesn't matter, we have it here, okay? Now, when we do the hard reset over here, when obviously what it says, when the asynchronous inputs, when the reset is high, the Q is going to go low no matter what happens. Okay, well, let's see. Oh, it did. Now, anything happens that we do? Nothing. This thing is tied into the reset position until we release that. Okay, now, doesn't matter what's happening here. Oops, let's just set it to, there you go. There we go. All right. Now, when we have, no matter what we have here, if we press the set button, it is going to be a hard set. Doesn't matter what's happening and where and who says what and how. This whole thing is going to go into the set because it's called a hard set. Okay, let's press it. Press it now. Okay, it did. Now, if this thing remains high because it's active high, active set, and look, it doesn't matter what we do here, doesn't matter what we do. Really makes no difference. This thing is going to stay that way. All right? So we just confirmed the truth tables for the synchronous and asynchronous inputs for the D-latch, and we just took a look at some possibilities of where you might find those devices. So look at those numbers, see how they look, and analyze some data sheets.